Hello everyone, a very warm welcome to this video. In this video we are going to talk about scheduling or job scheduling. On a very high level, scheduling in Hadoop administration term means what if there is X resource and there are multiple people who are looking for or they are fighting for resources. How will that work out is what we are going to see in this particular video. Now, before we jump into it, let's quickly see what we are going to see in this particular video. So to understand scheduling, it's important that we understand how yarn works. There are two types of schedulers. There is one which is fair scheduler and the other which is capacity. Now, Cloudera for production recommends fair scheduler. This is the only scheduler that Cloudera recommends for fair. So this video is majorly going to concentrate, or this course is majorly going to concentrate on fair scheduler. But before we really talk of how fair scheduler works, let's quickly talk about how yarn works and what is the concept of container. Now, when you go for when you fly from, let's say, New York to San Francisco, the unit of resource that you book on a flight is a seat. It's a seat. Or if you're watching a movie, the unit of resource is a seat. If you let's say buy a scoop of ice cream, so the unit is scoop of an ice cream. So similarly, the unit of resources in yarn is called as container. It is called as container. So container is a slice of RAM plus CPU. Some CPU plus some RAM makes a container. So let's understand how that works. So we have a cluster. Now the unit of resources in this particular cluster would be called as containers. And a starting point is number of CPU cores minus 1. So what that means is, if each machine has 8 CPUs, this cluster totally has 8 minus 1, 7 multiplied by 5, 35 containers. There are 35 containers in this particular cluster. So the capacity of this cluster is 35, and that is just a starting point. Now take example that in a flight, if everything is economy, you may have 32 or 30 multiplied by 6, that's around 180 seats. Now this 180 seats is the dimensions of, it's because of the dimensions of the aircraft. Now in the same aircraft, if you want to also have business class, then in the same space, the size of business class seats is bigger. So let's just say that if there are 10 seats for business class, there'll be only 15 rows remaining for the economy class. So if you really see, number of CPUs minus 1 is just a starting point. It's as good as saying in a normal aircraft there could be 30 rows of economy. But if somebody wants 10 rows of let's just say business, then only 15 rows are remaining for economy. So that's the same point. Typically it's 35 containers, that's number of CPUs minus 1. But if somebody wants bigger containers, so the size of containers will reduce, or the number of containers will reduce. So how it works is, let's say from your machine, if you submit a program is given to resource manager, and let's say there is MR App Master. So resource manager tells MR App Master that, okay dude, there is a new job for you, get started. So MR App Master may get initialized on any one machine. So that's the first container gone. So right now we have 34 containers. Now based on the number of containers required, the MR App Master will request the resource manager that for this particular job, I need one container of 4 GB RAM, 2 CPU on node 1. One container of 4 GB RAM, 2 CPU on node 2, and so on and so forth. Based on that, the resource manager will start awarding the resources on, let's say, node 1, 2, 3, and 4. Based on that, the resources get allocated. Immediately, if there is another app or another program submitted, there'll be another app master running on some other machine for another program, and that app master will ask for certain resources, and that's how this whole thing works. So the unit of resources is container. Container is nothing but a piece of CPU and RAM. So just to reiterate, unit of resource in YARN is container. Container is a slice of CPU and a slice of RAM. So slice of CPU plus RAM makes a container. Now, why are we really discussing this is because the next topic of job scheduling deals with the fact that if number or if demand of resources is more than the resources we have, how will resources be distributed? So basically, if the demand for resources is 4x and we have x, how will resources be distributed is the crux or motive of this chapter. So if there are 4 teams in an organization, they are fighting for resources. How will these resources get distributed is what we are going to see in this particular section. So now we are clear with how YARN works. Let's understand what's scheduling and let's understand what is fair scheduler. Scheduling is an art of assigning resources to the one who needs it the most or deserves the most. A real world example of scheduling could be airlines. Airlines have X seats to be given away. So airlines have X seats to be given away, and if the demand is less than X, it's well and good. If the demand is more than X, majorly the scheduling algorithm used by airline companies is first come, first serve. So that's a classical case of scheduling. Airlines have X number of seats. They are willing to give those seats. Their job is to somehow fill the seats to whoever needs it or deserves it the most. If the demand is less than X, so if airline has 100 seats and there are 50 passengers, no problem. But if there are 100 seats and there are 200 people asking for it, the scheduling algorithm that airlines use is called as first come, first serve for the most part, unless there are some quotas. For most part, it's first come, first serve. Whoever reserves it first gets it first. Now, very similarly, the job of YAR is to give resources to someone who needs it or someone who deserves it the most. Okay. Now, if demand is less than supply, there is no reason to worry. So if demand is less than supply, we don't have to really get into scheduling at all. But if demand is more than supply, YARN uses fair scheduler. So airlines use first come, first serve, whereas YARN uses fair scheduler. So what is fair scheduler? The word itself conveys fair means be fair to everybody. Be fair to everybody. So in this particular section, we are going to go deep into fair scheduler. So let's understand what exactly is fair scheduler. Now the dictionary meaning of word fair is equal. And fair scheduler is completely true to its meaning. So fair scheduler is completely true to its meaning. So let's understand what do we mean. So in a cluster, let's say we have 30 GB RAM. So the total capacity of the cluster is 30 GB RAM, for example. So what happens is, it's Monday morning and John comes to office, submits a job that needs totally 300 GB. So what really happens is, John gets all 30 GB and in 10 waves or batches, John should be done. So Monday morning, John is in office. He needs, so the total capacity we have in the cluster is 30 GB and John needs 300 GB. So what John gets is, John gets all 30 GB and within 10 waves of execution, John will have everything. Now, let's say by the time John completes its second, or let's just say that John has completed its fifth wave. John has completed its fifth wave and John is remaining with another 150 tasks. Around John's fifth wave, David joins in. and David needs 90 GB RAM. So what happens is typically system will wait for John to complete this execution, and now John gets 15. So he's remaining with 150 tasks. John gets 15. Will end up running 10 waves. Why? Because in first 5 waves it did 30, 30, 30, 30, 30, and remaining 150. Now he has to go for 10 batches because he's getting 15 slices. And within 10 batches John should be done, and David gets 15 GB, and in 6 batches David should be done. Now around John's and David's fourth wave, that is, they are going to complete 60 GB worth work. Daryl joins in with the requirement of 6 GB. So as soon as John and David were utilizing half of the cluster, Daryl also joins in after their fourth execution. So now what happens is, it's pretty important. John now gets 12, David gets 12, and Daryl gets 6 GB. So the reason is, fair scheduler will fairly distribute its resources to everyone, but if you don't need resources, fair scheduler will not give it. So an important key takeaway here is, true to its word, fair scheduler will be fair to everyone and equally distributes the resources But if someone, in our example it was Daryl, required less than 10, that is 6, so Daryl ends up getting 6, and remaining 24 were distributed as 12 and 12 among John and David. So this is how fair scheduler works by default. So true to its meaning, fair scheduler is a scheduler that basically lets you, or by default it works in such a way that everybody gets equal stuff, which is amazing. But is that really good for production? It's not good for production. Imagine you are a pre-sales guy and you're signing contract with a customer where you right now don't even know how many people are going to submit the job, and there is no visibility on how many resources you will have. So a better idea is that, can fair scheduler also have some kind of SLA or some kind of predictability? Yes, it certainly can have some kind of predictability. So let's talk about that predictability. So the predictability is called as min resources. So what exactly is min resources? Let's discuss that. Now, true to its meaning, fair was always going to be fair to everyone, and that was not really a great idea for production deployments. That was not a great idea for production deployments. What we really wanted is there should be some reservation also. For having predictability of resources, we have a facility called as min resources. Min resources means there is minimum resources given to a certain group. So let's say we have a group called as production, and it's actually called as a queue. So jobs could be submitted in, let's say, production queue, and as an admin we can configure that, whenever production is in the game, production gets 20 GB RAM. So if production team, somebody from production team is in the game, he gets 20 GB of RAM, that's it. No matter what. Whether what others are getting does not matter. He would have certainly getting, or he'll be certainly getting 20 GB of RAM. So let's understand this with a scenario. So here we have 30 GB. In this case, we have 30 GB. Now first, John comes in and gets all 30. Next, David comes in and they both get 15 and 15. But as soon as production comes in and say production needs 100 GB, the first thing that happens is first 20 GB is given to prod and remaining 10 GB is distributed among John and David. That's how min resources work. That is how min resources work. So min resources work in such a way where you have complete predictability. So as an administrator, you can configure that, okay, this is what I really want. If somebody comes from production, we should have this many resources. That is how you get your min resources. So in here, what we've really seen is first, fair means literally fair. So it's great, but not recommended for production deployments. For prods, we can use a min resources feature, and that min resources feature will reserve resources for us. So where do you set fair scheduler? So in etc Hadoop conf, there is a ready-made file called fair scheduler.xml. In there you can basically set all the values. Now, how does a fair scheduler thing would look like? So here we could, let's say, have a thing like queue name is equal to production. So anyone from production queue we say min resources 20. That means 20 GB RAM. That means any job submitted in the production queue will certainly get 20 GB of RAM. And how do you define queue? When you are submitting your job, we can say job dot queue dot name is equal to production, and in the background you can define who is having access to production queue, your input path and output path. So whenever this job is submitted, and if this job requires, let's say, more than 20 GB, 100% 20 GB would be given to this. 100% 20 GB will be given to this. This is how min resources work. So a quick summary, what we've seen so far, we've seen how YARN works, how resources are scheduled. We've seen how FAIR scheduler works. FAIR, true to its name, is basically a resource manager that basically fairly shares the resources, but that's not great for production. So that's why we have something called as min resources. Now capacity scheduler works exactly same way. There is one major difference. In FAIR scheduler, you can have 40 GB RAM, but when you assign resources, you can even assign 400 GB. An example would be if 1,000 people want to watch a movie, if there are 100 seats, cinema can take a booking for all 1,000 and allocate shows to them. Now this is not a very accurate example, but let's just say that if there are 1,000 people who want to see the movie, the cinema hall can do an advance booking and give them all the seats. And if there are 100 seats, people can have multiple shows and get it. Whereas in capacity scheduler, everything has to before itself at 200%. That means in capacity scheduler you can say production will have 55%, R&D 20%, and sales 35% or 25%. So in the beginning itself, we will have to give pools and resources be allocated according to that. So in FAIR scheduler, you can commit more than you have and then it could run show times. In capacity scheduler, everything has to before itself add up to 100%. So it's slightly more static. Now when it comes to Cloudera's Hadoop, the only scheduler that Cloudera recommends you for your production is FAIR scheduler. Capacity scheduler is recommended by Hortonworks, not Cloudera. So what we've seen so far in this particular session is we've seen how YARN works, we've seen FAIR scheduler and capacity scheduler, and that kind of sums up the entire scheduling process. To view scheduling URL or monitor scheduling, you can simply go to your resource manager 8088 scheduler and you can see how resources are getting scheduled right now. So that brings us to the end of this video. Thanks for watching this video.